Hello and welcome to Maths with Jacob. This lesson will focus on problem solving using concrete materials. Using concrete materials is one option we can use to solve problems. This method allows us to see what is going on with the problem. It is very useful for visual learners. Example 1. 4 squares are constructed side by side using matchsticks. Each square shares at least one common match with the adjacent square. How many matchsticks are used? Well, if we take the first square, forget about all the others, we can see that you definitely need 4 matchsticks. So there's the 4 there. For the next square, we already have one matchstick there. So we have another 3. 1, 2, 3. There. For the next square, we've already used this one, so we have another 1, 2, 3. That's there. And for the last square, we've already used this one, so we have 1, 2, 3. There. So the total number of matchsticks, you just add those numbers, and you have 13 matchsticks. Example 2. 15 marbles are shared equally between 4 people, and the remainders are put to one side. How many marbles does each person receive, and how many remainders are there? Let's pretend the 15 marbles are in a box. There are the 4 people, so start sharing them out. You give out 1, 1, 1, 1. So that's 4 you've given out altogether. Give out 1, 1, 1, 1. 8 altogether. Do the same again. So look what you've done. You've already given out 12 marbles. That means they have 3 each. 3, 3, 3, 3. Now that's 12 marbles. In other words, you've only got 3 left. So that is not enough to give them 1 each. So there's the remainder. So your remainder, the total for the remainder is 3. And they get 3 each. Example 3. Bill has 2 rows of apples with 4 apples in each row. So there's the 2 rows. 1, 2, and there are the 4 apples in each row. So Bill's apples total 8. That's easy to see. Sue has 4 rows of oranges with 5 oranges in each row. So we have 5, 10, 15, 20, because there are 5 in each row. So Sue's oranges total 20. So the total number of fruits, all we did was 2 times 4 gives you 8. That's there. 4 times 5 gives you 20. That's there. 8 plus 20, 28 pieces altogether. Example 4. 3 dice are placed on a table. What is the total sum of all the dots on the 3 dice? I'll say that again. What is the total sum of all the dots on the 3 dice? That is every single dot, not just the ones on the top, but all of them. Noting that each die, because die is singular, has 6 faces. So altogether we have to take into account 18 faces. Here's the solution. Consider one die. That is the singular. We've done that before. The singular of dice is die. On one of these, pretend it's this one, the sum of the numbers are 1 plus 2 plus 3 plus 4 plus 5 plus 6. So when we add all those up, we get 21. Since there are 3 dice, the total sum will be 3 times 21, and that's 63. So all the dots for all these 3 dice add up to 63. Example 5. How many matchsticks are needed to make 2 squares and 2 triangles? The squares share one common match. The triangles don't share common matches. The squares and triangles are separated. Okay. So let's do the squares first. The squares share one common match. In other words, that's the only way you can do it, because there's 1, 2, 3, 4, and these squares here, they need an extra 3 for that square there. So in other words, the squares have 7 matches. Here are the triangles, and it says the triangles don't share common matches, so they're separate. So that's 3 plus 3 is 6. So the squares have 7 matches, the triangles have 6 matches, so the total number of matches is 13. So you've seen some examples there where we can use concrete materials to solve problems, because you can see what's going on then, and it does make the process a little easier.